Hello, you are welcome to another episode on Tomex Academy. Please kindly subscribe to our YouTube channel so that you won't miss any of our video. Today, we are going to be talking about acid, base, and salt. Under this, we are going to explain characteristics of acid, base, and salt, pH, and pOH scale, that is power of hydrogen and power of hydroxy, as power of hydrogen ion and power of hydroxyl ion. Learning outcomes. At the end of this lesson, learners will be able to 1. Distinguish between the properties of acids and bases and identify the different types of acids and bases. Determine the basicity of acids and differentiate between acidity and alkalinity using acid-base indicators. Perform simple calculations on pH and pOH and identify the appropriate acid-base indicator. This is starter video. You can watch this for further explanation. An acid. An acid is a substance which in aqueous solution produces hydrozonium ion or hydrogen ion as the only positive ion. Also, acid can be referred to as proton donor. Classes of acids. There are two classes of acids. 1. Organic acids and inorganic acid. Organic acid occur as natural product in plants and animals. Example of organic acid, we have ethanoic acid, lactic acid, citric acid, up to ascorbic acid, which is vitamin C. Inorganic acid. Inorganic acid can be prepared from mineral elements or inorganic matter. Example of inorganic acid, we have hydrochloric acid, tetraisosulfate 6 acid, and triazonitrate 5 acid. And these are the formula. These are the constituent of hydrochloric acid, we have hydrogen and chlorine, and constituent of H2SO4, we have hydrogen, sulfur, and oxygen. Take note that some of these acids has code names like H2SO4. Another name for this, the code name for H2SO4 is sulfuric acid, while HNO3 is nitric acid. Now, let's talk about the strength of an acid. The strength of an acid can either be weak or strong. Strong acids are acids which ionize completely in aqueous solution, and such acid solution having a high concentration of hydrogen ion. Examples are HCl, H2SO4, and HNO3. Aqueous solution. The word aqueous solution, it simply means the solvent that was used to dissolve the acid is water. Now, hydrochloric acid. In aqueous solution, we're going to have the hydrogen ion plus chlorine ion. Tetrasulfate 6 acid, in aqueous solution, we're going to have this. Now let's talk about weak acids. Weak acids are acids which ionize or dissociate slightly or partially in aqueous solution. I've told you what aqueous solution means. Simply means when the solvent is water. So weak acid, as the name implies, weak acid. So they are partially or slightly, they dissociate slightly or partially in aqueous solution. And such acid solution have a low concentration of hydrogen ions. Examples are ethanoic acid, carbonic acid, and H2SO3 and H3PO4. So these are the following are the equation of reactions. Now let's talk about basicity of an acid. The basicity of an acid is the number of replaceable hydrogen ions, that's H+, in one molecule of the acid. If you look at this now, hydrochloric acid, the basicity of hydrochloric acid is 1. Why is it 1? Because the replaceable hydrogen ion here is 1. As you can see, it's having 1 hydrogen ion. Sulfuric acid, that's H2SO4. The replaceable hydrogen ion, you can see, is 2. So basicity of sulfuric acid is 2. So we call them dibasic. This one we call it monobasic. And we also have other examples like carbonic acid, just like I mentioned in the previous slide. Also sulfurous acid. Now phosphoric acid, that's H3PO4. Phosphoric acid has 3 replaceable hydrogen ions, so we call them tri-basic. So now let's talk about physical property of acid. They have a sour taste. 2. They turn blue litmus paper to red. 3. They are corrosive in nature, especially the strong acid, which means they can kill. So concentrated acid, they are corrosive in nature. It's not something one can use to play. In aqueous solution, they conduct electricity. Now let's talk about chemical property of acid. Reaction with metals. They react with metals to liberate hydrogen gas and salts of metal. Example, hydrochloric acid plus zinc solid. This will give us zinc chloride plus liberated hydrogen gas. Generally, when acid reacts with metal, we have acid plus metal, it will give us salt and hydrogen gas. 2. They react with soluble bases to form salt and water only. This reaction is known as neutralization reaction. So neutralization reaction is a reaction whereby acid reacts with base to give salt and water only. And a good example of neutralization reaction is H2SO4 plus 2KOH, and this will give us potassium sulfate, K2SO4 plus water only. So this is a good example of neutralization reaction. Now, preparation of acids. Acid is prepared by direct combination of the constituent element in the presence of a catalyst. The gas form is then dissolved in water. Direct combination of constituent elements. like constituent element for hydrochloric acid, we have hydrogen and chlorine. So this can be combined together directly, that's as you can see in the equation of reaction. H2, that's hydrogen gas, plus Cl2 in gaseous state, in the presence of activated charcoal, and this will give us hydrochloric. This will give us hydrogen chloride gas. So this gas can then be dissolved in water to get hydrochloric acid. This acid is prepared by the displacement of a weak acid or a volatile acid from its salt by a strong acid. The strong acid here is H2SO4. So, and when this reacts with weak acid, this will give K2SO4 plus HNO3, which is another strong acid. Uses of acids. They are used in the manufacture of drugs, fertilizers, soaps, and detergents. Industrially, some acids are used as drying agents, oxidizing agents, and catalysts. Bases and alkalis. A base is a substance which will neutralize an acid to yield a salt and water only. Most oxide and hydroxide of metals are bases. Example, sodium oxide, potassium oxide, magnesium oxide, sodium hydroxide, and potassium hydroxide. These are some of the examples. An alkalis is a basic hydroxide which is soluble in water. It's a basic hydroxide which is soluble in water. Example, we have sodium hydroxide, potassium hydroxide, and calcium hydroxide. A basic oxide or hydroxide is a metallic oxide or hydroxide which contains ions and will react with an acid to form a salt and water only. Now, as we have strength of acid, we also have strength of base. The strength of a base can either be weak or strong. Weak base are base that ionizes slightly in aqueous solution to produce positively charged metallic ion and negatively charged hydroxide ion. This is an equation of reaction. When ammonia plus water, this will give us ammonium ion plus hydroxy ion. So ammonium ion here. So this will give us ammonium ion plus an hydroxy. Strong bases. Strong bases are bases that ionizes completely in aqueous solution to produce positively charged metallic ion and negatively charged hydroxyl ion. So the following are the equation of reaction. Physical property of bases / alkalis. Alkalis have a bitter taste. Alkalis are soapy to the touch. Alkalis turn red litmus blue. Concentrated form of the caustic alkalis of sodium hydroxide and potassium hydroxide are corrosive. Chemical properties of bases/alkalis. Neutralization reaction. Bases react with acids to form salt and water only. Following are the equation of reactions. Bases react with ammonium salt to liberate ammonia gas. These are the equation of reaction. Uses of alkalis/base. Sodium hydroxide can be used to manufacture soap, and it can also be used to manufacture plastic using petroleum refining. Potassium hydroxide can be used in the manufacture of liquid soap, used in dyeing and electroplating. Calcium hydroxide can be used in the manufacture of mortar, cement, plaster, and used in dissolving acidic soil. Magnesium hydroxide can be used in the manufacture of toothpaste and used as laxative. Aqueous NH3. This can be used for bleaching clothes, used as detergent. Now, let's talk about measurements of acidity and alkalinity as the pH scale. pH is defined as the negative logarithms of the hydrogen ion concentration to the base of 10. While pOH is defined as negative logarithm of the negative logarithms of the hydroxide ion concentration to the base of 10. The number 7 on the pH scale represents the condition of exact neutrality. Numbers less than 7, that is pH 654, indicate increasing acidity as the number decreases. Number greater than 7, that is pH 8, 9, 10, indicate increasing alkalinity as the number increases. Students should take note. If you have 14 now as a pH, it means that that substance has high alkalinity compared to if another substance has pH of 10. So the higher the value, the higher the alkalinity concentration. But the lower the number, the higher the concentration for the acidity. If you have a substance with pH of 2 and another substance with pH of 5, it means pH of 2 has strong acidity than pH of 5. I hope this is clear. Now, relationship between pH and pOH. From conductivity measurement, concentration of hydrogen ion multiplied by concentration of hydroxy ion is equal to 10 raised to power minus 14 in this unit. Therefore, pH plus pOH is equal to 14. These are established value. Now, let's look at these examples. Find the hydrogen and hydroxide ion concentration in A, 0.01 mole per dm cube tetrasulfate 6 acid solution, B, 0.01 mole per dm cube potassium hydroxide solution. So the first thing we need to establish here is to write the equation showing the ions present in the aqueous solution. So when H2SO4 dissolve in water, we are going to have these ions, that is the hydrogen ions and the sulfate ions. Now, from the equation, we can see that 1 mole of this, 1 mole of H2SO4 ionizes to give 2 mole of what? Hydrogen ion plus. So therefore, the question that we're asked, therefore 0.01 mole per dm cube of H2SO4 would ionize to give 2 times 0.01, that's cross multiplication. If 1 mole of this give us 2 mole of H plus, then 0.01 will give us, we're going to cross multiply, that's 0.01 times 2. So, which means the H plus present in the 0.01 mole per dm cube is now 2 times 10 raised to the power minus 2. Now, we are now going to use our formula from conductivity measurement. That is to say, concentration of the hydrogen ion multiplied by concentration of hydroxyl ion give us 10 raised to the power minus 14. Sorry. We have gotten our hydrogen ion. Then we substitute for that. Then we have this. All we need to do is just to make a hydroxyl ion, that's the whole H, as the subject of formula. Then we have this. The B part also will be done just like how we have done in the A part. KOH, then this is the equation of reaction to give us potassium plus hydroxyl ion. So 1 mole of KOH ionizes to give 1 mole of this. Therefore, 10 raised to the power minus 3 mole per dm cube of KOH will give, this is 1 to 1. So it will still give the same value. That's 10 raised to the power minus 3 mole per dm cube of hydroxyl ion. Now, using the conductivity formula, concentration of this multiplied by concentration of OH minus will give us 10 raised to the power minus 14. Then here, since we have gotten the hydroxyl ion, in order to find the concentration of hydrogen plus, we make hydrogen plus as the subject of formula. So we're going to get this. Acid-base indicator. We know that some substances change color when they react with an acid or a base. These substances are called acid-base indicators, which can show us if a substance is an acid or a base. So the following are some of the indicators we have and the color change. So if you see, this is the red litmus paper. An acid is red. So, and when the pH is 7, it's also red. In base, it's blue. And blue litmus paper in acid is red. And the color is neutral, is blue. And in base, basic medium, as when the pH is greater than 7, it's blue. So we also have other indicators like phenolphthalein, colorless in acid, colorless when pH is 7, and pink slash red when the pH is greater than 7. Salts. A salt is referred to as the compound form when all or part of the ionizable hydrogen ion in an acid is replaced by a metallic or ammonium ion. So e.g., when hydrochloric acid reacts with sodium hydroxide, we have sodium chloride. Types of salt. 5 main types of salt are normal salt, acid salt, basic salt, double salt, and complex salt. Normal salt are the salt form when all the replaceable hydrogen ion in the acid has been completely replaced. A good example is sodium chloride. Then we have acid salt, are formed when the replaceable hydrogen ion in the acid are only partially replaced by a metal. A good example is sodium hydrogen tetrasulfate 6. And this is the equation of reaction. Then we have basic salt. Basic salt are formed when only part of the hydroxide ions of a base are replaced by the negative ion from an acid. Example, we have zinc hydroxide plus hydrochloric acid. So, and we're going to have this plus water. So we can see that in this equation of reaction, only part of the hydroxide ions of a base are replaced by the negative ions. That's as we can see from here, the hydroxyl ion here we have 2, but here it becomes 1, so it's not completely replaced. So we have basic. When you see this type of formula, it's talking about basic salt. So let's talk about double salt. Double salt are salts which ionize to produce 3 different types of ions in solution. Usually 2 of these are positively charged while the other is negatively charged. So a good example of double salt is this: ammonium ion 2 tetraosulfate 6 hexahydrate, or aluminum potassium tetrasulfate 5 dodecahydrate as potassium. Then we have complex salt. Complex salt contain complex ion. A good example is sodium tetrahydrozozincate 2. And we have potassium hexacyanoferrate 3. So these are examples of complex salts, and the following are the equation of reaction. Preparation of soluble salts. The method of preparing a particular salt depends on its 1. Solubility in water, 2. Stability to heat. The method used in the preparation of soluble salts are: 1. Neutralization of an acid by an alkali. So this is base and this an acid. So neutralization reaction happens with salt and water only. Action of dilute acid on a metal. So this is a metal, calcium, then hydrochloric acid. So we also have, in this reaction, we also have salt is also produced. We have calcium chloride plus hydrogen gas. Calcium chloride is the salt here. Action of dilute acid on triazoxide carbonate 4. Dilute acid here is H2SO4 and triazoxide carbonate 4, that's CaCO3. Then it's going to produce calcium sulfate as a salt, also water plus carbon 4 oxide. Action of dilute acid on an insoluble base. Dilute acid is H2SO4 here, and insoluble base here is copper oxide. So, and when this reacts, we have copper sulfate plus H2O. Preparation of insoluble salt. Insoluble salt can be prepared by the following method: 1. Double decomposition or precipitation. And these are the equation of reaction. 2. Direct combination of 2 elements, that is, combination of individual elements like iron plus sulfur, and we give us iron sulfide. So iron plus chlorine, we also give this. Then we talk about uses of salt. The following are some of the uses of salt, like this: ammonium chloride is used as an electrolyte in dry cell, that's Lanklache cell. Also, this is used as medicine to neutralize acidity in the stomach. Also, calcium chloride is also used as an antifreeze. So, calcium sulfate is used for making plaster of Paris, and also copper sulfate is used in dyeing and calico printing. Then we have come to test your understanding. We have been discussing about acid, base, and salt. So students, I believe you should be able to attempt this question. The following acids are monobasic, except, of course, we have talked about this. The following acids are monobasic, except it simply means which one is not monobasic. And it's clear, the one that is not monobasic is D. That's H2SO3. A solution with pH 7 is, of course, is neutral. Question number 3. An ionic compound that is formed when an acid neutralizes a base is called, of course, the answer is D, salt. You should be able to solve this. A glass cup of orange juice is found to have a pOH of 11.4. Calculate the concentration of the hydrogen ion in the juice. Of course, if you remember the formula I told you, pH plus pOH from conductivity is equal to 14. So that's an hint. You should be able to solve this. And in case you are confused or you don't know how to go about it, we have the solution on the next slide. So the answer, this is the answer to the question number 1 and answer to question number 2. Answer to question number 3, the salt, and this is the solution to the calculation. Just like I said, pH plus pOH equals to 14, then our pH will be 2.6. Then we are now going to use pH formula. That's pH is equal to negative log of hydrogen concentration. Then we are going to substitute for our pH, which is 2.6. Then from here, we are going to get our antilog of minus 2.6. So, and concentration of hydrogen ion is this. You can try. So we have come to the end of today's class. In this lesson, you have learned that an acid is substance which in aqueous solution produces hydroxonium ion or hydrogen ion as the only positive ion. pH is defined as the negative logarithm of the hydrogen ion concentration to the base of 10, and pOH is defined as the negative logarithms of the hydroxide ion concentration to the base of 10. A base is a substance which will neutralize an acid to yield a salt. And water only. Most oxide and hydroxides of metals are bases, e.g. sodium oxide, potassium oxide, and magnesium oxide. Then an alkalis is a basic hydroxide which is soluble in water. A good example is sodium hydroxide, potassium hydroxide, and calcium hydroxide. Then we'll talk about salt. A salt is referred to as the compound form when all or part of the ionizable hydrogen ion in an acid is replaced by a metallic or ammonium ion. Assignment. So these are the assignments. So please do remember to check this question, do the assignment, and we are going to see in the next class. Please subscribe to this channel if you have not, and thank you for joining us on today's episode on Tomex Academy. See you in the next class.